Automatic transmission fluid is pressurized by the transmission oil pump that is driven by the engine. The pressurized fluid flows through the transmission to engage and disengage the clutches and actuators. A valve body, usually located at the bottom of the transmission, controls the fluid flow to these clutches and actuators. Clutches are attached to the planetary gear sets that create the different gears in the transmission. The transmission fluid keeps moving parts inside the transmission lubricated and cooled. The torque converter is a fluid coupling that connects the engine to the transmission. At slow engine speeds, the torque converter slips to allow the engine to continue running even when the vehicle is stopped. As engine speed increases, the torque converter transfers power to the transmission. Transmission fluid collects inside the sump or oil pan at the bottom of the transmission before being sucked back up by the oil pump. The transmission cooler line carries transmission fluid to the radiator or transmission cooler. The cooler lines are usually metal lines with rubber hoses crimped on the ends, allowing the hose to flex. When a cooler line begins to leak, it should be replaced to prevent the transmission from being damaged by low fluid levels. Some transmission fluid coolers are located inside the end tank of the radiator. Coolant that has just passed through the radiator passes over the transmission fluid cooler and lowers the temperature of the transmission fluid. If the cooler develops a leak, the pressurized transmission fluid leaks into the cooling system and mixes with the coolant. The resulting mixture is more viscous than coolant and will not flow through the cooling system as it should. Coolant mixed with transmission fluid will not cool the engine properly and must be flushed immediately. The transmission fluid pan acts as a fluid reservoir for the transmission. On some vehicles, the pan is removable from the transmission. A common leak on the transmission is the fluid pan gasket. Most fluid pan gaskets are easily changed. As transmission fluid ages, oxidation occurs, and acids, varnish, and sludge are formed inside the transmission. Before a transmission fluid service is performed, a chemical solvent may be added to the transmission to clean varnish and sludge deposits. When the chemical is added, the sludge and varnish are dissolved into the fluid and then removed from the transmission when the fluid is replaced. Transmission fluid replacement can be performed either as a drain and fill service or by using a fluid replacement machine. When using a fluid replacement machine, one of the transmission cooler lines is usually disconnected. The machine inlet is connected to the cooler line, and the machine outlet is connected to the transmission cooler. The engine is then started, and the transmission pump circulates the old fluid into the machine, while new fluid is pushed through the cooler and into the transmission. When clean fluid starts returning to the machine, the procedure is complete. The machine is then disconnected and the transmission line is reattached to the transmission fluid cooler. The drain and fill service often includes replacing the transmission pan gasket and internal fluid filter. First, the drain plug is removed to allow the fluid to leave the transmission. The pan is then removed so access can be gained to the transmission filter. The filter is removed and debris is cleaned from the transmission pan. After installing a new filter, the pan is reinstalled with a new gasket. New transmission fluid is added to the transmission, and as soon as it reaches the appropriate level, the vehicle is started and the fluid level is checked again. A drain and fill service replaces most, but not all of the transmission fluid, whereas a machine service replaces all of the fluid, but not the internal filter. Combining both methods ensures that all the fluid and the internal filter are replaced.
The mechatronics unit inside the direct shift gearbox, or DSG, controls the flow of high-pressure hydraulic fluid to engage and disengage the clutches and select the correct gear. Before removing the mechatronics unit, the fluid is drained from the gearbox. The black plastic inner tube is used later to ensure the gearbox is refilled to the correct level. The position of the gearbox is adjusted, then the oil pump and mechatronics covers are removed. The mechatronics unit is removed. The replacement is installed. Sensors are reconnected, then the covers are attached and the gearbox is installed into the correct position. The gearbox is refilled with the correct hydraulic oil through the black fill tube shown earlier. The engine is run until the hydraulic oil is at the correct temperature. Any excess oil flows out through the fill tube before replacing the drain plug.
If you drive a four-wheel or all-wheel drive vehicle, you may need to perform regular maintenance on your transfer case. The transfer case controls which axle power is sent to. The transfer case might be manual, where the driver is required to select two-wheel drive or four-wheel drive, but on most newer vehicles, the transfer case is automated and uses sensors and electronically controlled clutches to send power to each axle depending on the driving conditions. The fluid inside the transfer case lubricates and cools the clutches and gears, and usually contains additives that minimize oil foaming and create the correct friction properties. Heating and cooling of the fluid, along with the accumulation of clutch material, can lead to fluid breakdown. This is especially true when the vehicle is used for towing or frequent off-road use. Fluid replacement should be carried out according to the manufacturer's maintenance schedule. If you drive a four-wheel or all-wheel drive vehicle, you may need to perform regular maintenance on your transfer case. The transfer case controls which axle power is sent to. The transfer case might be manual, where the driver is required to select two-wheel drive or four-wheel drive, but on most newer vehicles, the transfer case is automated and uses sensors and electronically controlled clutches to send power to each axle depending on the driving conditions. The transfer case uses a high-strength chain to transmit power from the engine to the front differential. Chains can become damaged as a result of harsh gear engagement or low fluid level inside the transfer case. Worn or damaged chains can cause further damage to the transfer case gears. Correct fluid level and quality can reduce the risk of chain damage. If you drive a four-wheel or all-wheel drive vehicle, you may need to perform regular maintenance on your transfer case. The transfer case controls which axle power is sent to. The transfer case might be manual, where the driver is required to select two-wheel drive or four-wheel drive, but on most newer vehicles, the transfer case is automated and uses sensors and electronically controlled clutches to send power to each axle depending on the driving conditions. Damaged or worn transfer case seals can allow fluid to leak. Running the transfer case with low fluid can cause internal damage to gears and clutches, potentially causing the transfer case to fail. Leaks should be repaired when discovered, and the fluid should be replaced to remove any internal debris. If you drive a four-wheel or all-wheel drive vehicle, you may need to perform regular maintenance on your transfer case. The transfer case controls which axle power is sent to. The transfer case might be manual, where the driver is required to select two-wheel drive or four-wheel drive, but on most newer vehicles, the transfer case is automated and uses sensors and electronically controlled clutches to send power to each axle depending on the driving conditions. Road materials and hazards can damage the transfer case, leading to a fluid leak. If your transfer case is damaged, you should have the vehicle towed to your service center for repair to avoid further damage to the internal components.
Components of the driveline are designed to smoothly transmit the rotating power of the engine, while still allowing suspension to flex and wheels to alter direction. Front wheels are usually driven by an axle that includes constant velocity, or CV, joints. Differentials allow for the turning rate of a pair of wheels to be different, which is necessary during cornering. Four-wheel drive vehicles have two differentials, one for the front wheels and another for the rear wheels. A transfer case is a switchable gearbox that delivers power to the front and rear differentials. The transfer case is connected to the differential by the driveline. All-wheel drive vehicles use a similar concept. However, the transfer case is replaced with a center differential, which usually allows more or less engine power to be delivered to each axle. The axle bearing is located at the end of the axle tube and is lubricated by rear differential fluid. The bearing also rides on the surface of the axle. When the gear oil becomes low, or if the fluid is contaminated, the bearing may not be lubricated sufficiently. This causes excessive heat around the bearing, and the heat causes the metal to become pitted or worn, especially on the axle. Axle bearings are usually accessed by removing the brake drum and the axle, then removing the axle bearing seal. If the surface of the axle has become worn due to the worn bearing, both the axle and bearing will require replacement. The rear differential transmits torque from the transmission to the rear wheels of the vehicle. The rear differential normally consists of a pinion gear, a ring gear, 2 spider gears, and 2 side gears. The 2 side gears are connected to the axles, which drive the rear wheels. When the vehicle is traveling in a straight line, the pinion gear transfers power to the ring gear, which then transfers power to the side gears. When the vehicle is cornering, the wheel on the inside of the corner is traveling a shorter distance and therefore needs to be able to turn slower than the wheel on the outside of the circle. When this happens, the spider gears rotate and allow the side gears to travel at different speeds. When the spider gears become worn, the side gears and spider gears do not create a tight mesh and can skip over each other. This usually makes a loud popping noise when cornering. Bearings inside the differential support the shafts to which the gears are connected. If a bearing becomes worn, it can cause the gears to mesh improperly. This usually creates a humming noise from the rear of the vehicle and can cause premature wear on the gears. Differentials are enclosed in a metal housing that is filled with fluid that allows the gears to be lubricated and cooled. Multiple seals keep oil from leaking out around the rotating shafts of the differential. If a seal begins to leak and the fluid level becomes low enough, the gears will not receive sufficient lubrication and damage can occur. The universal or U-joint is connected to the drive shaft of the vehicle. It allows the shaft to bend while still transmitting power from the transmission to either the front or the rear differential. Each U-joint has 4 trunnions, and each trunnion is surrounded by needle bearings. A bearing cap is placed over the bearings, and a seal at the end of the cap seals the lubricating grease inside and keeps moisture out. Over time, the seal wears out and allows moisture to enter the bearing cap and contaminate the needle bearings. With no lubrication, the needle bearings become worn and cause looseness in the joint. A common symptom of a worn U-joint is a popping noise under acceleration. U-joints can be checked for looseness by grasping the drive shaft firmly and moving it up and down. If any movement is visible, the joint is worn out. Rear differentials are normally found on trucks and 4-wheel drive vehicles. The rear differential is filled with fluid or gear oil in order to lubricate the moving gears. Rear differential fluid should be changed at manufacturer-recommended intervals. The interval for heavy-duty vehicles is usually shorter, as towing or hauling heavy loads can cause the fluid to degrade more rapidly. When rear differential fluid is neglected, it leads to the breakdown of the gear oil and can cause the differential gears to wear, causing the differential to become noisy and eventually leading to the failure of the differential. A rear differential fluid service is significantly cheaper than replacing a complete differential assembly. A constant velocity, or CV axle joint, allows the engine power to be transmitted from the transmission to the wheels at a variety of different angles. Almost all axles that send power to the front wheels use CV joints. The CV joint is lubricated with heavy grease and is covered with the CV boot. When the boot is torn, the grease leaks out and the CV joint overheats. This normally makes a loud clicking noise when the vehicle turns at low speeds. When a CV boot has been torn, replacement of the complete CV axle is usually recommended. The vehicle body systems include components that are related to vehicle occupant safety and comfort, and some other areas not included in underhood sections. Restraint system includes the seat belts, seatbelt latches, pretensioners, and airbag systems, including the clock spring assembly that connects the airbag and steering wheel buttons to the vehicle wiring. Other body system components include windshield wipers, lighting systems such as turn signals and headlights, and passenger comfort items such as power windows and power seats.